Look how, I mean, the colour, again, showing you on this cam. This is a live cam. It's white. Indeed, it is a simulator that's in the skies. Look at all this. Very unnatural formations. They've been spraying the skies, and these parts as well, proving that everywhere is being chemtrailed.
Hey, is that birds there? And I am seeing a blue sky, but where are the chemtrails that are hiding the planet in our sky?
Everywhere is being sprayed, is it, Matthew? I do not think so. As can be seen by this video taken in Bendigo, Australia on the 4th of November 2017. And since then, there have been many more days as clear as the one seen here. In fact, I've invited you to debunk my Clear Skies video, but you choose to delete my comments and any others that may not agree with your opinions. So, my friend, they are not spraying chemtrails everywhere.
Look, there are birds in this clip, and I thought Matt said that nowadays you don't see birds anymore. And that all the trees are dying off due to the spraying, but I see there are healthy trees in this clip. Matt wouldn't lie to me. Would he?
This isn't our sun. Can you see this on the screen just here? It's so obvious, isn't it? That they're using this reflector.
A reflector, is it? Really, Matthew? You leave so many unanswered questions. How big is it? How did it get there? Who controls it? What does it reflect? Let's see what happens when we place a reflective device between the Earth and the Sun, shall we? Oh, darn. Seems as though we need a light source in front of the reflector. Just where's the secondary light source coming from? Now, let's see what happens when we turn off the secondary light source. Oops, not looking good for a reflector then. Think we can put a big red X through the simulator being a reflector.
Hey, but people tell me there is a patent for a solar simulator and I've looked it up. So it must exist, right?
Yes, you are correct there. But if you check further, you will find there are 2 patents and an actual simulator that has been built in Germany. However, it pays to do your research. These solar simulators are designed to be used in a lab to test solar panels and other materials to be used on spacecraft. They are not designed to work in the vacuum of space. The reason these simulators are needed is because our atmosphere blocks a great deal of the radiation that would otherwise affect the materials in space, and the atmosphere also diffuses the amount of light the materials would be subject to in a space environment. So, it actually pays to fully read patents and news articles from reliable sources about a sun simulator.
I've heard multiple sources say the sun is white, that it just looks yellow because the Earth's atmosphere is scattering the blue light. I've heard in other places that the sun is yellow because of its position in the Hertzsprung-Russell (HR) diagram. Which is it? It can't be both yellow and white at the same time, or can it?
Actually, the sun emits a lot of energy in the visible range. In wavelength scale, it is from 390 nanometers to 700 nanometers. And when you translate it to colours, you get all the colours from violet to red, just as we see them in a rainbow. When you mix all these colours together, you get white, and that is why white is the true colour of the sun. Check out photos of the sun taken by astronauts with no filters on their cameras. The sun appears white on them.
It's shown here in my quick little graph that I show, and the flickering sun is caused by the those high-speed objects or other celestial objects that are breaking the beam, or debris in the debris tail, breaking the beams of these microwave beams between the satellite, sending the microwave energy to the rectennas that convert the microwave energy into electricity, which power the lasers, which powers the sun simulator. So there's still a real sun, but here's the simulator in an orbit. It's approximately distance of 250 miles above the Earth, and the diameter of this sun simulator has been measured now by scientist Dr. Albers. By the angle of the light that's coming off the sun simulator has determined this is roughly 300 feet in diameter. Now, the moons or objects could be also between the solar panels of the solar collectors that collect the energy, which I think is probably more likely than breaking the microwave beams. This would be dang close. The distance of these microwave beams could be up to 27,000 miles and are 1 billion watts apiece per beam. That's a lot of power. So if we had an object here, about now on the topic of the stationary planets, if the object was seen where my cursor is, it's very faint, I'm sorry about that. If the object would be here, the light would be bent through this lens and onto this lens, and then eventually casting a holographic planetary object here. So the light is being bent through a series of lenses and maintaining, so no matter where this planet is out here, it appears still in a holographic image here. Once it leaves the lens array, then it could move all around. And I believe these are overlapping lenses. I'm going to make another video in greater detail of what these lens arrays really look like.
All right. Jeff P tells us the simulator is in orbit some 250 miles above the surface of the Earth and has been determined by a scientist to be about 300 feet in diameter. And of course there's a bunch of satellites each sending 1 billion watts per beam to power this simulator. Fair enough, but before we move on, let's look at those figures in a little bit more detail. 300 foot sounds big, but do you realise that's the size of your average soccer pitch? Do you really think you would even be able to see a soccer pitch 250 miles away? Let alone have it block out the sun? Let's just compare that with the ISS specifications. The module length is 167.3 feet or 51 metres. The truss length is 357.5 feet or 109 metres. The solar array length is 239.4 feet or 73 metres. The mass is 924,739 pounds or 419,455 kilograms. It orbits at a height of 254 miles or 408 kilometres, and its orbital period is 1.6 hours. So, its truss length is roughly equivalent to Jeff P's simulator, as is the size of the solar array. And it looks like the height of its orbit pretty close as well. So my question is, why do we not see the ISS eclipsing the sun or the simulator at least a couple of times a day? Well, simply because it can't. Here's a time-lapse photo taken during the recent eclipse, and you can actually see the ISS crossing the sun. So, a 300-foot simulator seems to be on shaky ground, I would suggest. Alright, now let's try and apply some scientific facts to the simulator. Point 1. The size of said simulator would have to be the size of Earth or bigger, at least 12,000 kilometres. Why, you ask? The sun does not illuminate just one small point on the Earth, it covers the whole daylight side of the planet. That is simple and can be explained with an analogy. I live in Australia and I have a friend in New Zealand. The sun is so far away that both me and my friends see the sun at the same position in the sky, almost exactly relative to the distant stars. But if there was something between us and the Sun and close to Earth, we would see the simulator at different positions relative to the Sun through parallax. In other words, it's the simulator we see at different positions relative to the distant stars rather than the Sun. It's like looking at, say, a distant mountain. If you look at it with a left or right eye, it seems in the same position relative to even more distant mountains. But hold a finger in front of it and your eyes will see the finger at a different position relative to the mountain. If it was hovering in front of the Sun, or close to it, it would be as big as the Sun to block it out, which is huge. Generally it would be between the two in size, but if closer to Earth, it would need to be around the diameter of the Earth or a bit larger. Point 2. That's okay, I hear you say. It's very big, but it's in geostationary orbit. Sorry, that doesn't work either, simply because anything in geostationary orbit stays over the same point on the Earth at all times. So, if it is in orbit above, for example, the longitude of Australia, then when it's night in Australia, the simulator is on the night side of Earth, so it can't be blocking out the Sun for anyone. Moving on to point 3. Now you have to find somewhere to put this simulator so it hides the Sun but isn't being dragged back to Earth by gravity. I take it you've heard of gravity. So, we suggest you put it 1.5 million kilometres out in space at what is called the L1 point or Lagrange point, where the Earth's gravitational field and the Sun's gravitational field nearly cancel each other out, and it's somewhat easier to keep something in the same spot. After all, who wants to be moving the simulator all the time? By the way, a kilometre is about 0.6 miles in case you live somewhere that hasn't caught up with the rest of the world in our metric ways. Now, this is doable, but even at the Lagrange point, station keeping is a bit like balancing a pencil on its sharpened point. It takes a lot of work. Also, the simulator would need to be manned for minor repairs, as something the size of this simulator is sure to get hit by meteors at some stage. So now we have a space flight out to L1 at least every few months for resupply and crew change. Okay, let's sum it up for you. We have a 12,000 kilometre wide disk floating out in space that is some sort of huge light globe. It can't be a mirror because, as we saw earlier, it would need a secondary light source. It is 1.5 million kilometres out in space, so all you need to worry about is if something goes wrong and it breaks down. Most of the truther channels agree that it is breaking down because they've shown film of a flashing sun. Now, should the breakdown happen, you'd better hope the Sun's gravitational field grabs it first, because if it decides to come hurtling towards Earth, you won't have to worry about Nibiru or anything else, because something the size of your simulator, not my simulator, will not burn up in the atmosphere. It will break up and spread a large swath of debris across the planet, and the chunks will be that big that it will be no good to duck and cover. And let's conveniently forget how much such a project as building your simulator would cost, let alone the number of launches and workers it would take to get the parts into place, also that it was built without anyone seeing it under construction. Maybe they did it at night. Oh, that wouldn't work, would it? With the current heavy lifters available, that's Chinese and US rockets, let's look at some details and some real math on this project. For the point of this argument, let's suppose the Sun simulator is 1 millimetre thick and similar density to water, which is 1 tonne per cubic metre, although I think most lenses would sink in water. So, with a radius of 6,371 kilometres, then the volume in cubic metres, and so the mass in tonnes, is 0.001 multiplied by pi multiplied by 6,371,000 multiplied by 10 to the power of 2 tonnes, or around 127,500,000,000 tonnes. If both the US and China were doing, say, 1,000 launches a day, then it would take them 127,500,000,000 divided by 10 multiplied by 2,000 multiplied by 365, which works out to 17,500 years to complete the project. So construction started on your sun simulator during the Upper Paleolithic period when humans were still using stone tools. How unlikely is that? However, if both the US and China were doing 1 million launches a day, or a launch on average of every 11.5 seconds, then the construction would still take 17.5 years. Now, obviously, there's no way you can launch a rocket every 11.5 seconds from the same launch pad. Instead, since the turnaround time is bound to be more than a day, they would both need millions of launch pads to do it in a reasonable timescale. And that doesn't explain how this 1mm thick lens system achieves what they want. And you have to figure out how to keep it from folding up or moving away from its unstable equilibrium point at L1. It also has to be several times the diameter of Earth to match what you claim to be its size in your sun halo photos. And just think what an astronomical spectacle it would be, with millions of spaceships going up there every day to ferry all the materials up to make it, and the lens or mirror gradually unfolding in a space construction project billions of times more ambitious than the ISS. Honestly, it's an absurd idea.